Hi, let's talk about structs. So when you want to group together related data which are of different types, we can use struct. If you see map, I can have all the keys of the same type. I can't have one key of string, another key of int. So in such cases, we can use struct. We define struct using type keyword, next the name of the struct, and the struct keyword followed by open and closing braces. Within these braces, I have fields of struct. Each field has its name and type. So this is a struct person1 which contains name, age and pet fields. Once a struct type is declared, you can define a struct variable. So here is a variable Tulsi which is of type person1. So 0 value of a struct as every field set to the field 0 value. That means name will be a null string, age will be 0 and pet will be a null string. We can access the fields in struct using dot operator. Yeah. So it's null string, 0 and null string. Now you can assign values to those fields using dot operator. So we'll say 23 and a null string. You can also use colon equal to operator with struct literal, which is person1, and you can see this is an empty struct literal. I can also have non-empty struct literals where I can assign values to the fields in a struct. There's also another type of non-empty struct literal where you will be using, which looks similar to map, where you'll have field name followed by value. So before that, let's try without pet name, and you can see we get an error saying too few values in the struct literal. It means in this type of non-empty struct literal, you need to have all the field values, you need to have all the fields that I have defined in this struct. Let's go to type 2. This style allows you to omit few fields, and you can also change the order of the fields. I can mention pet here. See, that's valid. Next, let's come to anonymous structs. Anonymous structs is where we declare a variable that implements a struct. So person is a variable where you can see it's not type, it is where, which implements struct. So you can't do something like where x person. That is not valid because person is not a struct type. Same way, this is another type of anonymous struct declaration. So you can see Bob 50 and dog, Bob 50 and dog, and Fido dog. That's it. Next, let's look at comparing and converting structs. You can compare two structs if the fields in both the structs are comparable. We have already seen that slices and maps are not comparable. If the struct contains these data types, that means you can't compare these structs. Coming to the first point here, Go doesn't allow comparison between variables that represent structs of different types. So what it means is, I have a struct of type first person and struct of type second person which look the same. The order and the name of the fields are same. X is a variable of type first person and Y is a variable of type second person. Let's try comparing them both. And you can see invalid operation, mismatched type. First person and second person are two different struct types. We can't compare them even though they look the same. You can compare two variables which are of type first person. Right? That's valid. Go allows you to perform type conversion from one struct type to another if the fields of both structs have same names, order and types. You can do type conversion between first and second person because the type, order and name of the fields are same. Coming to third one, the order of the fields are different and you can't do type conversion. Age is coming first, but here name comes first. Coming to fourth person, the field name is different and type conversion is not allowed. For fifth one, we have an extra field favorite color, and so type conversion is not valid. Let's try converting X and Y to second person. You can see that's valid. That's it for structs. Thank you.